Electric potential due to a uniform electric field. Up until now, we've dealt with electric fields and potentials due to individual charges. What is much more interesting and relates more to practical applications is when you have configurations of a massive amount of charges. You can see where we're starting to go here. There's a lot of positive charges up here on this surface and a lot of negative charges on the surface down here. We begin by examining two infinite planes of charge that are separated by a small distance. Here's one infinite plane, here's the other infinite plane. It's rather hard to draw infinities, so just try and imagine this goes on forever and ever. The planes have equal amounts of charge, very important. One plane is charged positively, the other plane is charged negatively. This is actually an idealized picture of a critical electric circuit element, the capacitor. We'll talk more about the capacitor in the next chapter, and then electric circuits will be explained in the next unit, so we're kind of preparing you for all that. We're going to work with electric field, electric potential energy, and electric potential to explain this configuration, which will also explain the theory of the capacitor. We can use Gauss's law. Now, unfortunately, we won't be talking about that until APC physics, but the result of that is that the strength of the electric field, that's the blue lines here, will be uniform between the planes. It will have the same magnitude and direction everywhere between the planes. So you can see how these lines are the same distance apart, they all point in the same direction. This is a uniform electric field, these blue lines. And the electric field outside the two planes, here, 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 anywhere outside will equal 0. Let's show the difference between what we did before and what we're doing now. We originally worked with point charges, and this is a non-uniform electric field. It gets smaller the further away you are from the charge, and you can see the field is pointing in all different directions. Only some of the equations that we've learned will apply to uniform electric fields. And again, let me just kind of circle these blue lines here. These represent a uniform electric field. They have constant magnitude and constant direction.